Greetings, folks. Today we are working on a visualization of polyrhythms in processing, which is a Java library for graphics, a graphical library. This is my first stream on this channel, so forgive the technical issues if there are any. I've already set up a lot of the boilerplate code here. We've got a sketch. I'm using processing via the Maven package instead of through the UI, so I'm just running it directly. I'll be running it from the command line, and I'm just editing text files in Sublime Text. And so what's going on with my sketch? And generally what I do with processing sketches is I load in some parameters that I've defined in a protocol buffer, or just a proto as it's called. This is like JSON if you're not familiar, but better. It serializes more efficiently. You can represent it in plain text. So I'll define a proto for anything I want to parameterize, like colors or positions. And I'm just pulling in the file location of that text proto that I'll define using this Apache Commons command line library. And I've also written some scaling to scale everything down for the stream, and because I don't have great graphics, like a great GPU on this machine. So I'm going to scale everything down by some number that I specify, and I'll parameterize this as well. So yeah, let me pull up the chat so I can see it. Sorry about the furnace noise. Not much I can do about that. It's freezing cold right now. I wonder if there's a way to float the chat. I'm such a noob with OBS. Oh well. Let's just start coding here. So first what I want to do is actually load in this proto. And use my parameterized width and height. Oh, right. And so also what I usually do is define a class around the proto for the parameters that does other tasks like load the proto from file or create other abstractions on top of it. So we'll start with int width and height. But I'm also going to need to define this parameter class. In the same package. I'll give it a private constructor. Yeah, and we'll just pass it the proto. Make make sure we import that. So that's the name of it. Just say from proto for the static factory method. Constructor. File. And this will be able to load a text proto file where I've written in the parameters. And I'm just going to copy paste some boilerplate for this from another similar file. And we're using this text format from protobuf package. This will possibly throw an exception. Multiple types. I'll just throw exception, I think, which is not good practice, but this is just for creating a visualization, so it's not going to be deployed as infrastructure anywhere, so I'll just throw exception if something goes wrong, rather than writing IO exception and whatever the protobuf exception is if it can't parse it. And we'll do this. Let's see if that compiles. MCP is just my alias for Maven clean package. And something's wrong. Oh, missing field number, of course. When we define a proto, we need to add tag numbers. And these start at 1 usually, and well, you can't use 0 as a tag, and you ascend from 1. So let's try that again. Right, and now we'll need to import these. I want the name of the proto here, not the class. Okay. Let's see if that works. Variable params, yes. Okay. Then we need to define a method, public method, to retrieve the proto. Alright, so this is within another package that I use for a lot of these visualizations. So there's other unrelated code, and really I should be breaking this into its own package, but that is for a later date. By the way, in the bottom right, that's the processing logo that you see here. Okay, that's compiled, so let's define an actual text proto file. Just need to pick a directory, which you're not seeing on the stream, but it's happening. Call it Polyrhythm timeline. Uh, 1920 for the width and 1080 for the height, because I'm going to scale it. So I'll add this scale factor now and set it to 1/4, 0.25, and I'll add that to our proto here as a float. Scale factor. So now in here, rather than just defining this, we want to go. I can store the proto as well within this class, since I'll be accessing it so much. And I'll just say, oh, yes, we're going to want that. We'll just set the proto to that. So now I can access the proto directly if I want. And here we'll go proto.get scale factor. So now it's going to fetch that scale factor from the proto. So I should just need to change it in the proto. And we didn't compile here, from proto file. Let's call that from proto file. And then I didn't update scale factor somewhere. Here we go. That actually I don't want to invoke. I just want to, every time I use an X or Y coordinate, I'm going to manually call this SCL method, which is kind of ugly, but it's good for the stream, I think. We're going to parameterize this font later as well. Okay, let's try running this. And passing it the proto file, see if everything goes well. And it should just spit out a hello world. Okay. Looks good. So what's next here? That's most of the boilerplate, I think. probably think about other parameters we're going to want to add. Colors like background color. And I'll just specify this as an RGB string. Because that's how I like to do it. So the string will contain something that looks like that. And I wrote some code to parse strings like that into processing's color format already. So we have the background color. We're going to have a cursor moving along the screen, hitting these polyrhythm points. So cursor color. And then I'm not exactly sure of the layout for the other things, but we will want margins because we don't want to go all the way to the edge of the screen, I think. So I do have a margin proto somewhere that I've already defined. Here. Margins proto, just with left, right, top, and bottom. And I'll need to import that other proto file. Position proto. Is that it? Yeah. Poor naming there. Position proto dot proto. But that's okay. So let's see. What we can do right away is, let's say, draw background, which is background is the function for that. And our color will be here. So what I'm going to do though is cache a color object. In this class. I think it's from RGB. Let me check that that's my method from RGB string. Get background color. That looks good. And then we'll want public accessors for that. And now in here, I can just say params dot background color dot red. Is it? Yeah, I think that's the right method. Red, green, and blue. Probably I just want a method draw background where I do this. Now in our parameters, let's define background color, RGB, some kind of dark gray. I'm just going to Google RGB color picker for a quick visualization tool. 56, 56, 56 looks okay for now. So let's try recompiling. I'm going to need to import the color class. A lot of this import stuff you would get if you used a heavyweight IDE like Eclipse or IntelliJ or one of those, but honestly, I prefer the plain text approach. It's not worth all the headache of all the things going on behind the scenes that you're not really privy to. So I like to just plain text and command line it, usually. Okay, that looks good. There's our background color. Can you see that? Let me make sure. Yes. All right. So we also want to parameterize this font. I'll just add a font parameter and say font. And here we'll just call proto.getFont. These getters are generated automatically when you define a proto. This is the syntax for accessing it in Java. These classes are generated by the protoc tool, proto-C. It compiles the proto, so to speak, into source Java files, which can then be built into your project. And that's all configured in my pom.xml with these plugins. Auto value is a separate thing. With this whole thing, in case you're curious. And you have to include the dependency for the actual protobuf library as well. Now, let's see. What's next? Streaming code is a different ballgame. It's like there's this constant background pressure, like someone's watching. Because even though almost no one's watching, maybe one person's watching, it still has a different vibe. So I was doing the font thing, and I added it. I went on a bit of a tangent there, explaining stuff. Let me know if you want more explanation and slower coding, or less explanation and just kind of head down, pounding it out as quickly as I can. Let's make sure our font still looks the same. Yep, it does. So that was this. This can just stay a fixed number. I'm just creating the font at a high size so it looks good when we scale it down. It's just one of those aspects of how processing works. Let's see, other parameters. Cursor color, I'm probably going to want these up here. And I'll loop the colors, group the colors together. Keep these ascending. I actually wrote a little script that makes sure the proto tags are always ascending, so I can invoke that once this starts getting big and ugly. Maybe let's do the margins. Well, I guess the margins aren't relevant until we start drawing something, unless I'm going to draw a border. So maybe before we start drawing, we need to think about these polyrhythms that we want to draw. So I'm thinking things like 2/3, 3/4, 2/5, anything, any pair of numbers that is coprime, basically, meaning the greatest common divisor is 1 between the two numbers. Otherwise, it's a reducible polyrhythm, if you can call it that. You can always express it in a simpler way, or it doesn't create an interesting non-overlapping pattern, or it overlaps before the completion of the pattern, if that makes sense. So we're going to want to class dedicated to this. Maybe just coprime we can call this. Coprime calculator, let's call it, because I might want to have a separate object for coprime pairs. Yeah, I think I will. This is our package. Let's save this as a Java file so it starts formatting for us at least. And maybe this just needs static methods, so I'll give it a private constructor to help document the fact, or enforce the fact that it's not to be instantiated. So we're gonna need is coprime between two numbers A and B. So what is this gonna look like? That'll be, you could use Euclid's algorithm, like the GCD algorithm, and see if the GCD is 1. Maybe that's not the smartest way. Let's see. Let's look up that old Euclid GCD algorithm. Right, I think it assumes the first number is greater than the second. So we go, well, B is not equal to 0. And then we store the value in B. And we set B, oh, but usually I don't want to modify parameters that are passed in. But that's okay, I guess you can. A mod B. So now we're setting B to A modulo B. And set A to what B used to be. And then we're just going to return whether A is 0. If it's 0, they're coprime. Because it's worked all the way down and it hasn't found any common divisors. I think that's correct. We'll write some tests for this. We will write some tests. So let me create a new file, coprime calculator test. Again, this is off screen for you. But I'm just creating a new test directory. That looks good. And then let me just import the right files for JUnit. Okay, here we go. These guys. Oops. annotate this with test. And we'll just write one test case per pair of numbers. So 2 and 3. And I'm using truth here, which allows me to write these kind of statements that read like English. Assert that coprime blah is true. Of course, we need to reference the class. And while that's compiling, we can write a bunch of test cases. Ooh, and it failed. Okay. Was it false or was there an exception? What is this? It should say, but was false. Okay, so this is incorrect. Oh, yeah, it's not 0. It's if it'll equal 1. 1 is their greatest if that's another way of defining coprime. If 1 is the greatest common divisor. And in Euclid's algorithm, A is the greatest common divisor. So we're just returning if A is 1. Whoops. While we're here, we can say 2 and 2 is false, obviously. Oh, I didn't save that. Any number is not coprime with itself. You can divide it by itself. So let's see. There we go. Okay, now we're looking good. We can add a bunch more test cases, like 3 and 4. Now, will this work if I reverse the order? F equals B. So what if A is larger than B? Let's try. Let's try it. Hey, Grant. That's awesome. Looking forward to generating it for you. Ah, okay. Oh, that should definitely be true. So this is correct. Nice, Grant. Just working on a new video here and streaming the process to see how it goes. Haven't tried this before. There we go. View in live controller. That's what I want. Okay. Okay, looks like we're good to go. This can work in either direction. I can add a few more test cases. Test 3 and 4. It's true. 3 and, say, 6 should be false. And I don't know what else. 9 and 3 should be false. I should really, since we're streaming, I should write more complete test names. It's good to be verbose with your test names. Nine and 3, and you really want to talk about the data you're setting up and the expectation of the test, so that when it fails, it's clear exactly the case that's failing. Okay, and now for the coprime pairs that we want to use for polyrhythms, we are going to want to enumerate all the coprime pairs between, say, 2 and 10, inclusive on the 2, not inclusive on 10. So the actual data structure I want should probably be a coprime pair object. So let's make that. Just copy all this. And this is good for an auto value, which is another handy construction from Google. Basically handles a whole bunch of boilerplate for you. And I won't get into exactly how you use it if you're not familiar, but it basically does a lot of work for you. Let's say lower and higher. I don't know what to call these pairs. A and B, I could call them, but and now you can, I'll just make a static builder for this. And if A is greater than B, we're going to want to return the auto value class that's generated, coprime pair A, B. No. If A is greater, you want the lower to be B. Yeah. Otherwise, A is lower. I think that's right. I'm going to save this as coprime pair. Don't forget to call new on those objects. Nope. Oh. Yep. Gotta import auto value. which is com.google.auto.value. That should do it. Recompile. Static, yeah. Just need to give the method a name. Okay, that's good. Back to our calculator. So now we're going to want to define another static method to get a list of coprime pairs. Maybe an immutable list, actually. That's also from Guava, which is the Google Java extensions. I think it's common collect, immutable list. So we're going to want a list of coprime pairs between some minimum value and max. We'll make max exclusive just because that's the usual convention. I'll just make a quick note of that. So up to but not including max is what I mean. And this will be our result. Create an immutable list builder. And then we're going to need 2 for loops. So we'll start at min. I is less than, I guess, max minus 1. Because if we want everything, say, between 2 and 10, we only want to go up to 8 with the lower of the 2 digits. And then we'll set j equal to I plus 1. Nope, forgot to increment I in the loop. And we'll go until j is less than max. And increment j. Okay, now in here, we just need to check if is coprime I and j. Then we can add I and j to our list. And then we'll return the immutable list. Hey, thanks, Dragos. That's awesome. Thanks, man. Love to hear it. And let's see here. Let's just see if that compiles first of all. We can write some test cases for this as well. Oops. Caps lock, get out of here. What did I call this? Pairs. I don't really like that name. Let's be more descriptive. Coprime calculator dot, it's good enough. Pairs is good, given the name of the class. So we want to say coprime calculator dot pairs. And well, if we're going to be extra rigorous too, we can add a little precondition in here. Oops, import preconditions, but then we're going to want to check that max is greater than min plus 1. Right? Because it's not inclusive, so it needs to be at least 2 more than min. If that's not true, max must be I'll just write the values that were passed. Min, max. I should really, I gotta get like a sound when something goes down in the chat. maybe not. I don't know. Okay, that's just a little error checking, a little assertion. So, pairs. Let's say pairs between 2 and, I don't know, 6. We can easily enumerate those. So because we used auto value, now we can actually use equals on these objects and actually compare their contents, because it treats it as a value rather than, you know, comparing the address of the object, which is normally what happens in Java. So this will look like assert that this list contains exactly in order. Now in here I can add the pairs that I expect. So it'll be 2, 3, 2, 5, 3, 4, 3, 5, um, 4, 5, and that's it. So let's see, we'll run that, compile it, test it. Okay, I'm always suspicious when it passes on the first try. So let me change one to intentionally make it fail, just to make sure everything's good. I had this set to 2 and 2. Ah, see? Well, maybe I didn't save it on time. Let me try that again. Again, not trusting. Yeah, okay. That's what we wanted. We wanted a failure there. Looks good. Hey man, how's it going, Phoenix? Yeah, what's that? I do not know Minecraft Java things. I know Java things, but when it comes to Minecraft, I don't have a clue what sort of APIs they offer or what you do. I guess it's visualizations, 3D rendering sort of stuff, I would assume. Sorry. It's in Java. You got ratted? What does that mean? Is that like some Minecraft terminology that I don't know? Okay, I'm gonna parameterize the two values of the polyrhythms that I want. I have the logs, and I don't know what they mean. Oh. Yikes. How did that happen? What were you... Oh, you were running somebody's code or something? Gotta be careful. Gotta be careful out there. Okay. Back to what I was doing, though. I was parameterizing the min polyrhythm number. I hate writing the word rhythm. Typing it, I mean. It's always so awkward to type. So these are going to be my bounds for polyrhythms that I specify. That's too bad. I'm sorry, man. Maybe is wiping the slate clean an option? I don't know. If you ran somebody's arbitrary code, like, and gave it root, there's not much. Well, it depends on what the code did. If you know exactly what it did, maybe you can reverse it. Anyway, sorry, I don't want to get too sidetracked, which clearly I have the tendency to do. So in here, in our setup, we're going to want to pull in these two polyrhythms. Yeah, it was a jar file. Stole your passwords. Discord token. Wow. Brutal. Brutal. I'm gonna add a list of coprime pairs that I fetch in the setup method. In processing, this setup method is called before draw gets called in a loop. I've called no loop to stop the looping, but when we actually get to coding our visualization, we will take out no loop. Coprime calculator dot pairs. We want to go between get min polyrhythm number and get max polyrhythm number. You found the logs, Phoenix? I mean, yeah. I don't know. Change your passwords, obviously. That's about all you can do. So for now, let's just like print out these coprime pairs. Min polyrhythm number max. So for our actual visualization, I want to set these to 2 and 10. So I want single digit irreducible polyrhythms. Back to our sketch. So let's see. JSON rare exception dot crawl encrypted. I have no idea. I mean, some JSON thing was happening. Okay, let's run this. We should see a list of everything in the console output. Oh, you can't see the... Oh, you can. Never mind. So we should have a list here. Yes, 23, 25, 27, 29, 34, 35, 37, 38, 45, 47, 49, 56, 57, 58, 59, 6 over 7, 7, 8, 7, 9, and 8, 9. Okay, so we're going to iterate through all those and visualize what they sound like. So 2 over 3 is, you've got 1, 2, 3, 1, 2, 3, for instance. We're going to need some kind of like BPM parameter, or not BPM, but let's say duration of one pass. Let's call it pass duration, seconds. This is how long to play back, how long it takes to play back one pass of a polyrhythm pair. And maybe we'll start with 2 over 3. I'll just do this for now. I'm not making these private because this is the top level sketch in processing, so nothing's going to be looking at this class. Usually you'd always make your instance members private. But I'm not too concerned about that now. So just for initial developing of the visualization, let's get the first pair, which should be 2 over 3, given the parameters that I put in the proto file. And our pass duration seconds, so let's see. If we have 2 over 3, maybe we want like 1, 2, 3, 1, 2, 3. Maybe 2 seconds is good. Once we get up to the higher numbers, we can reconsider that later. We'll call the text font up here. That's not going to change. I'm only going to just write the current polyrhythm number. Oh, really? 360p? Ew. Thanks, Ricky. That's unfortunate. Let's see. What can I do? Stream health is excellent. Well, that's a lie. Hmm. 1080 by 360. Okay. Yeah, I want to change that. Okay, what if I hide everything for a second? Then will it let me change the settings without rebooting the stream? Settings. Sorry, I'm just digging through OBS. Yeah, okay, I think I need to stop the stream to fix that resolution. Is it really 360p? Oh yeah, 360p. Yeah, that makes sense. But yeah, that's clearly kind of lame. Okay, I'm gonna end this stream, and I will start another one up right away. See you soon.